Welcome to today's 5-minute lesson. Today I'm going to be continuing with physics. So usually the first thing you learn in physics after units and sig figs and all the basic intro stuff, usually you start off with kinematics. That's normally the first real topic. And kinematics isn't quite physics per se. A lot of actual physicists will claim it's not really physics. What it is basically a system for understanding the relationship between distance and time. Basically just those two, just distance and time and how they're related. So basically distance is an SI unit. It's a fundamental unit of just 1 meter. It's just this SI unit for distance, how far two-part things are. And another SI unit is time. That's also basic fundamental SI unit. That's, 1 second. There you go. 1 second is the fundamental SI unit for time. There are lots of other units of time and distance. Obviously, feet, inches, miles, kilometers, and then, minutes, hours, days, years, fortnights, no problem. They can be converted to meters and seconds, which normally you have to do when we are starting off with physics. Normally you are asked to work in SI units. Because, well, one major reason is that there are many other units of other things like power and force and work and all of that. And though we prefer the SI units for those, are much easier to work with, but we have to use meters and seconds because meters and seconds are part of force and work, etc. So, kinematics comes from, so kinematics, kinesis, telekinesis, kinesthetic, that means movement. And kinematics, like mathematics, like measuring of movement. So meters and seconds are basically all we're playing with. Basic definition of velocity, which is we see a lot. Velocity is change in distance over change in time. I'm going to be using delta x for change in distance. From a start point to the end point, that's going to be my delta x. And then in a change in certain amount of time, change in time. So delta x over delta t is my definition of velocity, how fast I'm moving at any given time. That should intuitively make sense because the most common measurement of speed we see, when we're driving at least, is miles per hour. That's not SI, but that is a measurement of velocity. Miles per hour means division, miles per hour. The other major thing we have to work with is the change in velocity over change in time. So the change in velocity over the change in time, that is going to be acceleration. So acceleration is how fast you're changing your speed. If your speed is not changing, your acceleration is 0. And this is the tricky thing. This is what one of the first things that trips people up a lot, is that you can be going fast and you can still have no acceleration. So if you're on the freeway going 90 miles an hour, and then you're still going 90, and you're still going 90, and you're not changing your velocity, the change in velocity is 0, your acceleration is 0. And people often make the mistake of thinking, oh, I'm going fast, well, I have a big acceleration. No, you don't, not necessarily. Maybe you do. If you pump the brake, your acceleration is negative, even though your velocity is still positive. Your velocity is still 80 miles an hour, your change in velocity was negative. And you can be not moving and have a strong acceleration. If, for example, we're just slamming on the gas, you haven't started moving, you're just at the moment you start to move, you have a high change in velocity because 1 second later you're going 20 miles an hour. So that's a big change in velocity, so it's a big acceleration, even though you at least started out, you didn't go that fast. So velocity and acceleration are what we deal with in kinematics. So those are the basic equations. Change in distance over change in time, that's velocity. Change in velocity over change in time, that's acceleration. Next video, we're going to see the basic kinematic equations and how those are all put together, and go from there. So thanks for watching today. Hope that's helpful.